Assalamualaikum and greeting for everyone. Today we will present our presentation for case study CHM260, which is the title that we choose for today is Qualitative Analysis of Ethanol in Local Alcoholic Beverage by using Gc-Fid. Before we go through to our presentation, let me introduce you our member of this group. Hi, my name is Nur Fatini binti Jafar and this is my member of this presentation, which is Nur Rika Shafika, Clay Shirley, and Chowena Owena. Introduction. In this study, the concentration of ethanol in the local alcoholic beverage is determined by using the gas chromatography with a flame ionization detection. Ethanol content in the alcoholic beverage is a critical parameter for regulate compliance and consumer safety. The accurate measurement of ethanol ensure adherence to legal limit and the quality of control standard in the production and the sale of alcoholic beverage. So what is Gc-Fid? Gc-Fid, or the largest name we can call as gas chromatography with a flame ionization detection, is a powerful technical technique used to separate and qualify volatile compound in the mixture. In this case, Gc-Fid will employ the separate ethanol from the other compound in the alcoholic beverage based on the difference in their volatiles. The separate compounds are detected by a flame ionization detector, which generate electrical signal proportion to the amount of ethanol present.
Let's begin with the methodology used in this experiment. First, we prepared the standard and internal solutions. This involved mixing 10 grams each of ethanol and acetonitrile into 1000 ml volumetric bottle, then adding distilled water to reach the 1000 ml mark. Next, we determine the relative response factor of ethanol and acetonitrile. We use ethanol at 1% volume and acetonitrile at 1% as a ethanol standard. By analyzing the area under the chromatographic curve, we calculated the RRF based on the concentration ratios. Finally, we use a direct injection gas chromatography or GC method. A 0.5 ml sample solution was mixed with 1 ml of the ethanol standard and diluted to 5.0 ml. From this, 0.1 ml was injected directly into the GC for analysis. Now, moving on to the data analysis. This is the chromatogram result showing the gas chromatograms of ethanol and acetonitrile. The peaks you see here represents the retention times for each compound, with acetonitrile appearing at around 2.135 minutes. From this, we can determine the concentration of ethanol in the sample by comparing the peak areas using the earlier calculated RRF. This method was a wide range of applications across various industries. It is used in food and beverage analysis, environmental monitoring, and forensic technology. In addition, it's essential in the petroleum industry and supports chemical research and development. These applications highlight how accurate and useful gas chromatography can be for detecting and analyzing volatile substances like ethanol.
In this study, acetonitrile was selected as the internal standard for quantifying ethanol in alcoholic beverages using gas chromatography, primarily due to its absence in such beverages, thereby minimizing potential interference and ensuring accurate quantifications. The choice of acetonitrile over other candidates like 1-propanol, 2-propanol, acetone, 1-butanol, and D-butanol was based on their possible presence in the alcoholic beverages, which could lead to overlapping peak and compromised accuracy. Utilizing acetonitrile simplifies the analytical process by allowing direct injection of sample into the GC system without the need of complex pretreatment procedures like dilution or distillation. The established relative response factor of ethanol to acetonitrile further enhance precision and reliability across varying ethanol concentrations commonly found in alcoholic beverages. Overall, this methodological approach not only ensures robust ethanol quantifications but also streamlines analytical workflow, making it suitable for routine quality control analysis in the beverage industry.
In typical studies, researchers measure the ethanol levels in different types of local alcoholic drinks like beers, wine, and spirits. This analysis reveals how ethanol content varies based on the beverage type and production techniques. Such investigations are crucial for producers to ensure their products meet quality standards and comply with regulatory requirements. In conclusion, gas chromatography with flame ionization detection proved to be a dependable instrument for precisely determining the amount of ethanol present in local alcoholic beverages. We can make sure that every batch satisfies quality standards and legal requirements thanks to its sensitivity. Gc-Fid helps us to ensure consistency and safety in the drinks we enjoy locally by giving exact data with minimal trouble. This process is necessary to keep our product true to their original intent and to satisfy customers who value our original brews.